9 plus 3 plus 1 plus 1/3 plus 1/9 converges to. We use the series formula, which states that s sub infinity is equal to a sub 1. What's a sub 1? A sub 1 is 9. It's the first term in the series. Over 1 minus r. What's r? R is the ratio, so we can see that it's decreasing by 1/3 each time. So our r in this case is 1/3. So we can rewrite that here, or we can write that here. This is equal to 9 over 3/3 minus 1/3, because 1 can be written as 3/3, which is also equal to 9 over 2/3, which can be rewritten as 9 times 3/2, if you remember your fraction rules, which is equal to 27 over 2. 7 cosine of 3t over 4 equals 6 within the interval 0 to pi. So we're going to rewrite this. 7 cosine of 3t over 4 is equal to 6. And really, this is a matter of just solving. So divide both sides by 7. This cancels out. We have cosine of 3t over 4 is equal to 6/7. Now, the trickiest part of the problem comes in. We're going to take the inverse cosine of both sides so that the cosine cancels out. So once we do that, we'll be left with 3t over 4 is equal to the inverse cosine of 6 over 7. Now we're going to multiply both sides by 4, and that'll cancel out the 4 in the denominator. We'll be left with 3t equals 4 cosine of -1 of 6/7. And now we're just going to divide both sides by 3 so that these cancel. And as our final answer, we will have t equals 4/3 cosine to the -1 of 6/7. Now we just have to check that it's within the interval. I know for a fact that this is equal to roughly 0.72. And since pi is 3.14, this is within the interval. F of x equals log of 4x over square root of 7x. So when we're determining the domain, we really need to ask on what intervals is the function defined. And so we will start, sorry about that, we'll start by talking about 7x. We can also think of this as just x, right? What values is this function defined on? Well, we know that x cannot be negative, right? X has to be greater than or equal to 0. And so that's going to be the case for this as well. We know that the denominator of this has to be defined for only positive or numbers or 0, essentially. So square root of 7x, actually, just rewrite this. Just write it as, really 7x has to be greater than or equal to 0, right? For log of 4x, well, we can also just ask what are the values for which log of x is defined? Well, log of x is defined when x is also greater than or equal to, I believe it's actually 1, right? No, it can be 0. It has to be greater than 0, right? So it has to be greater than 0. It can't be 0, but it can be greater than that. So since this is the most restrictive standard we need to meet, we know that f of x will be defined, f of x log of 4x over square root of 7x is defined when x is greater than 0, right? Now, there are no upper bounds for these functions because, I mean, log of 4x, x can get as big as you want in this function, and the same thing on the bottom function. For the square root of 7x, x can be as big as you want here. So really, we just need to meet this value. So we can rewrite this as x is defined on the interval from 0 to infinity. Remember to close the infinity with a rounded bracket or a parenthesis because we can never actually reach infinity.